Welcome to CSEC Mathematics with Mr. Charles. Today we are looking at number bases, and we're gonna specifically look at the base 10 and the base 8 number system. Now, when we are talking about number base system or number bases, we are talking about a system of counting. Okay, the system that we usually use to count is the base 10 number system. In that system, we count in groups of tens. All the digits from 0 to 9 are allowed. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All those digits are used to create all the numbers that we know exist in the base 10 number system. Now, I want us to spend some time looking at the place value system for base 10. We all are familiar with that place value system. So we have a decimal point, and to the left of the decimal point, we have the units place, we have the tens place, the hundreds place, the thousands place, and so forth. We can go up to 10,000s, 100,000s, millions, and so forth. And then to the right of the decimal point, we have tens, 1/10, hundreds, thousandths, right, and so forth. Now, the units place is the same as a ones place, and since that is a base 10 place value system, we can equate the units place to the value 10 to the power of 0, because any number raised to the power of 0 is equal to 1. So 10 to the power of 0 is equal to 1. Then for the tens place, the equivalent would be 10 to the power of 1, because any number raised to the power of 1 is a number itself. So the tens place is the same as 10 to the power of 1, which is the same as 10. And the hundreds place is the same as 10 to the power of 2, or 10 squared, which is 10 times 10, or 100. And the thousands place is the same as 10 to the power of 3, or 10 cubed, which is the same as 10 times 10 times 10, which equals 1000. When we get to the right of the decimal point, we have the tens place, which is the same as 10 to the power of -1. The law of indices tells us that 10 to the power of -n is the same as 1 over 10 to the power of n, right? Or you could say 8 to the power of -n is equal to 1 over 8 to the power of n. So if you have 10 to the power of -1, then that would be equal to 1 over 10 to the power of 1, which is the same as 1 over 10. And then the hundredths place would be 10 to the power of -2, which is the same as 1 over 10 squared, or 1 over 10 to the power of 2, or 1 over 10 times 10, which is 1 over 100. And then finally, the thousandths place would be 10 to the power of -3, which is 1 over 1000, or 1 over 10 times 10 times 10, right? Or I could say 1 over 10 cubed, right? So that is a place value system for the base 10 number system. So as I stated before, counting in base 10, base 10 is also called a decimal number system, and counting in base 10 means that you are counting in groups of 10. So after every 10 numbers, you move to another group. So all base 10 numbers are formed from 10 digits. So, and these are the digits from 0 to 9. You do not have a digit larger than 9, and any other number beyond 9 have to be a combination, any combination between those digits from 0 to 9. Right, so after 9 you would go 1, 0, which is 10, 1, 1, which is 11, and so forth, right? Combination of the digits from 0 to 9. Now let's look at an example where we actually have to determine the value of digits in certain places, or underlying digits. But before we go into those examples, I want us to keep in mind that if you are asked to find the total value, or the value of a digit, the total value of any digit, right? Sometimes you might just see the value, or you might just be asked to find the value. But when you're asked to find the value, then it means you have to find the total value. So it would be equal to the place value multiplied by the face value. And that is the equation you would have to use to determine the value of any digit at any position in a number, right? It's abbreviated TV is equal to PV times FV. The the place value has to do with the position of the digit. The face value is the digit itself. The face value is the face of the digit, or what you see. So the face value of 5 would be 5. The face value of 4 would be 4. The face value of 0 would be 0. So the face value is the actual digit. Good. So let's go back to the example. It says here, what is the value of the following underlined digits? And notice it did not say place value, face value, or total value. So when you encounter a situation like that, you are being asked to find the total value. So if you are asked what is the value, it means you have to find the total value. So what is the value of the following underlined digits? Well, here we have 27 base 10, or you could just say 27. 27 base 10 is the same as 27. But just to show that we are dealing with base 10 first, I choose to put the base 10 there. But anytime you see a number without a base, it's automatically understood that the number is a base 10 number, right? If it belongs to any other base system, then you would have to state the base. But we want to find the value of the 2. Now, first of all, let's identify the place values. So the 7 is in the units place, and since that is base 10, that would be 10 to the power of 0, because 10 to the power of 0 would be 1. And the 2 is in the tens place, that's 10 to the power of 1, because 10 to the power of 1 is 10. The total value of the 2 would be 2, which is the face value, times 10 to the power of 1, which is the place value. So face value times place value would be the total value, right? So we're still using that little equation there. So 2 times 10, right? Because 10 to the power of 1 is 10. So 2 times 10 is 20. So the total value, or the value of the 2 in 27 to the power of 10 is 20. For part B, we have 1086.25 base 10. So we have the 0. So the face value of the 0 is 0, okay, times the place value. Well, let's see. So this is 10 to the power of 0, 10 to the power of 1, and 10 to the power of 2, or 10 squared, right? So it would be 0 times the place value, which is 10 squared, and 0 times 10 squared is 0, because any number multiplied by 0 is 0. So it would be 0 times 10 squared, which is equal to 0. The face value of the 5 is 5, so it's 5 times 10 to the power of, well, this is 10 to the power of negative 1 here, and this is 10 to the power of negative 2. Remember the designations from up here, right? 10 to the power of negative 1, the first decimal place is 10 to the power of negative 1, the second decimal place is 10 to the power of negative 2. So 10 to the power of negative 1, 10 to the power of negative 2. So that would be 5 times 10 to the power of negative 2, which is the same as 5 times 1 over 10 squared, which is the same as 5 times 1 over 100, right? And then we could put the 5 over 1 and cancel. So we say 5 into 5, 1. 5 into 100 is 20. So we get 1 over 20 as the answer. Okay, that is the value of the 5 there, 1 over 20. Then number 2 asked, expand the number 5.625 base 10. So to expand the number, we first must identify the place value. So this is 10 to the power of 0, because it's a 1's place, and 10 to the power of 0 is 1. And then this is the decimal point. The first decimal place is 10 to the power of negative 1. Then we have 10 to the power of negative 2, 10 to the power of negative 3. So to expand it, we would say 5 times 10 to the power of 0 plus 6 times 10 to the power of negative 1 plus 2 times 10 to the power of negative 2, because the 2 is in the 10 to the power of negative 2 place, right? That's a hundredths place, plus 5 times 10 to the power of 5 times 10 to the power of negative 3. And 5 times 10 to the power of 0 is the same as 5 times 1, right? So that's 5 times 1 plus 6 times 10 to the power of negative 1, right? This is the same as 6 times 1 over 10 plus, right, 2 times 10 to the power of negative 2, that's 2 times 1 over 100 plus 5 times, right, 10 to the power of negative 3, that's 1 over 1000. And that is 5.625 in expanded form. Let us now look at the base 8 number system, the place value system of the base 8 number system. Okay, so we have the decimal point and we have places, place values values to the left of the decimal point. So this is left and this is right. So we have place values to the left and to the right of the decimal point. So we're in base 8. Remember, when we were in base 10, we had 10 to the power of. Now we're in base 8, we have to have 8 to the power of. So 8 to the power of 0, right? Immediately to the left of the decimal point, we have 8 to the power of 0. And remember, any number raised to the power of 0 is 1. So 8 to the power of 0 corresponds to 1, which is the units place, right? The units place, or the ones place, is also called the 1. It's still called the ones place. After 8 to the power of 0, we go to 8 to the power of 1, right? 8 to the power of 1 is 8, which is the 8's place. And then we have 8 squared, which is the 64's place, because 8 squared is 8 times 8, which is 64, right? So the 64's place, and then we have the 512's place, right? Because 8 to the power of 3 is 8 times 8 times 8, which is 512, so that's the 512's place. Then to the right of the decimal point, we have the 8th place, right, which corresponds to 8 to the power of -1, or in other words 1 over 8. Then we have the 64th place, which corresponds to 8 to the power of -2, or 1 over 64. And then we have the 512th place, which corresponds to 1 over 512, which is 1 over 8 times 8 times 8, 8 to the power of -3. Okay, so these are the place values of the base 8 number system, right? It's always 8 to the power of. Now base 8 is also called the octal number system, and when we are counting in that number system, it means that we are counting in groups of 8. Therefore, only 8 digits are allowed in that system of counting, and those 8 digits are 0, 1, 2, 3, 4, 5, 6, 7. Okay, the digits 8 and 9 are not allowed in the base 8 number system. So let's look at an example. We have here, what is the value of the underlying digits below? So our first one is 2073 base 8, and notice we do not say 2073 base 8, we say 2073 base 8. So we want to find the value of the 2 and the 7. So same thing, place value times face value. So the 2, the face value is 2, so 2 times, and so we have, this is 8 to the power of 0, 8 to the power of 1, 8 squared, 8 cubed. So 2 times 8 cubed, so that is 2 times 8 times 8 is 64, and 64 times 8 is 512, right? So that's 2 times 512, and 2 times 512 is 1024. Okay, so that is the value, or the total value of the 2, 1024. Then the total value of the 7, right, would be 7 times 8 to the power of 1, which is the same as 7 times 8, giving us 56. Okay, that's the total value of the 7 here, 56. Now for part B, we have 6654 base 8, 6654 base 8, and we want to find the face value. Well, the total value of this 6 here, the face value is 6. So we have to multiply that face value by the place value. So this is 8 to the power of 0, 8 to the power of 1, 8 squared. So the place value is 8 squared, right? And 8 squared is 64. 6 times 64, right? 6 4 is 24, 6 6 36, and the 2 is 38. So that's 384, and that's our answer here, 384. And then the 4 underlined here, the face value is 4. That's 4 times the place value, 8 to the power of 0. 8 to the power of 0 is 1, so that's 4 times 1, which is 4. Okay, so the value of the 4 here is 4. So the value of the 2 for A is 1024. The value of the 7 for the same A is 56. The value of the 6 for B is 384, and the value of the 4 for B is 4. Let's look at number 2. Expand the number 3062.71 base 8. Okay, so again, we have to identify the place values. So this is the 8 to the power of 0 place, 8 to the power of 1, 8 squared, 8 cubed. Okay, and here we have 8 to the power of -1, 8 to the power of -2. So then expanding it, we'll get 3 times 8 cubed plus 0 times 8 squared plus 6 times 8 to the power of 1 plus 2 times 8 to the power of 0. And and then plus 7 times 8 to the power of -1, as well as plus 1 times 8 to the power of -2. And then 8 to the power of 3 is 512, so that's 3 times 512, plus 0 times 64, right? Plus 6 times 8, plus 2 times 1, plus 7 times 1 over 8, plus 1 times 1 over 64, right? And that's our answer here. Next question says write the first 20 base 8 numbers. The first 20 base 8 numbers. So when we are counting, we start from 1. So we have 1 base 8, 2 base 8, 3 base 8, 4 base 8, 5 base 8, 6 base 8, 7 base 8, and we cannot have 8 because remember 8 is not allowed. So after 7 base 8 we have to say 1 0 base 8. We do not say 10 base 8, but we say 1 0 base 8. Then 1 1 base 8, right? 1 2 base 8, 1 3 base 8, 1 4 base 8, 1 5 base 8, 1 6 base 8, 1 7 base 8, 1, well, we cannot say 1 8 base 8 because 8 is not allowed, so we have to go to 2 0 base 8. Let's see how many numbers we have so far. We have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. We need 4 more because we want the first 20. So we say 2 1 base 8, 2 2 base 8, 2 3 base 8, and 2 4 base 8. So that these are the first 20 numbers in the base 8 number system, okay? And they correspond to the numbers 1 to 20 in the base 10 number system. So 1 base 8 is the same as 1 base 10, and 2 4 base 8 would be the same as 20 base 10, okay? So that's our listing there. So that's our answer. Thank you very much for being a part of this video. It has been a pleasure. Do enjoy.